Okay, so in topic 5, we're going to be talking about networking and communication. So, our objectives here, we're going to talk a bit about the history behind the development of different networking technologies. We're going to define some key networking technology terms, and we're going to talk a little bit about wireless and some of the different wireless technologies that are out there. So the function of networking, we use the term why networking. And really what networking is it provides an ability for computers to communicate with one another and to facilitate communications between users and groups using um, computers. So it's a computer, it's a function of computers. And if you recall when we talked around the essential components of IT. We talked about things like hardware and software. And we talked about networking being it's a combination of hardware and software. So it's a combination of hardware and software that really provide this capability for one computer to talk to another computer and exchange information and data. And in the video here, Computer Network Connect gives you a perspective of an example of kind of some of the mechanics of it. When we're talking around networking, the network, the first thing that comes to mind is the internet. All right, so the internet's actually been it's kind of an interesting history. So it is networking and the internet is a relative newcomer um, compared to like computers and systems. So computers and systems kind of came to the forefront in the 50s and 60s, whereas this concept of networking and kind of an overall networking really has not. It kind of came along a little bit later and kind of merged with computers, at that point downstream. So the internet itself was, the foundations of the internet were developed in 1968. ARPA, which is a government organization, put together a proposal um, for a communication technology that would allow for the communications of computers that were located from one side of the U.S. to the other. So it was kind of a combination of defense project along with research and development from academic institutions were really the big drivers behind this. And the original idea was ultimately being able to create a resilient communication system so that if one side of the country was destroyed in a nuclear attack, you'd still have the other half of the country that could still operate. So it was kind of a product of the Cold War to some degree. Um, so 68 was when kind of this initial stuff, the original work was kind of put forward. Um, it was kind of in the back office in the lab, and then like 78 to 83 was we were kind of developing what we call TCP/IP, all right, Transmission Control Protocol, Internet Protocol, which is really the backbone of they call it here a universal translator. Basically, it's a language that lets computers talk to other computers. Now, networking has been around before the invention of TCP/IP. We go back to the days of like IBM and other big computer manufacturers. Those companies actually developed their own networking that would work with their hardware. So, say for example, IBM had something they called Systems Network Architecture (SNA), and Digital had something they called DECnet, which would basically connect all of the digital computers together. And Apple originally had something called Apple Talk, which would let all Apple computers talk to each other. So it was really kind of designed to keep, communication between two individual types of specific types of boxes or types of computers. TCP was TCP/IP was a bit different because really it was designed so that any computer could talk to any other computer that was running TCP/IP. So it was a universal. So I think the focus on TCP/IP was that it was a universal translator that you'd be able to communicate across be able to talk. Whether that device would be a mainframe computer or whether or not it could be a smartphone. And the internet, when we use the term internet means an interconnected network of networks. Now, the World Wide Web is the internet kind of started out in the 60s. The, the what we call the World Wide Web, which is not necessarily the internet. It's a piece of the internet, but the internet is, it's the World Wide Web is not the same thing as the internet. So the World Wide Web is a even newer creation. Was originally designed or architected by a gentleman by the name of Tim Berners-Lee, who was a British software engineer and academic who, in 1990, put together a paper on this concept of what he called a hypertext, so the idea of creating a web of servers that it would communicate over the internet and use what we call hypertext to exchange information back and forth. So that kind of created, there was a couple of things that happened all in that time frame. Number one was Berners-Lee's and the creation of the World Wide Web. The other thing was in the early 90s, there was a shift of the internet, of basically the management of the internet, was shifted from National Science Foundation out to moved it basically from it being a very restricted academic military type of platform to in 91 making it a platform that could be used and leveraged for online commerce. And it was really a kind of a explosion of activity, kind of starting in 90 through 93. 93 was the creation of the first browser, Mosaic, which was the first browser to let you be able to leverage and access data within the World Wide Web. In 94, it was Netscape Navigator, which was the commercial application of a Mosaic browser. And really from like 93 through 2000, 2001, you saw a huge explosion of commercial activities and information and content activities that were on the internet. So we see here in 94 and 95, the creation of the e-commerce sites, Amazon and eBay, which are usually what we associate with being business on the web. But they were not what we see them as today. They were fairly small. Basically Amazon was just selling books. eBay was kind of just like a swap site. They've obviously have grown and have matured and it's changed quite a bit. But so through that time frame, from about 93 through about the end of the millennium, through 2000, there was a huge growth, and it was as they called it at the time, it was a bubble, the dot-com bubble, which was tremendous amounts of investments and kind of new ideas and new things coming out. But in 2000, 2001, you had kind of what they called the bubble burst. And it wasn't a technology problem, it was actually a business problem. Basically, people were, putting expectations and outsized expectations of what they were going to get from the internet. So what you saw was kind of the internet, the dot-com burst, but the technology itself continued to move forward. So a couple things about the World Wide Web. Just basically, what do you need? So there's a couple basic things. It's not the thing that makes the web successful is it's relatively simple. So it's not a particularly complicated, super complicated technology, which enables it to scale. And if you can take simple things and be able to repeat it again and again, you can develop very, very, very large platforms. All right. So basically, what you need to do is you need to have a server and basically install the web server software. So basically, it's what gets you onto the web. Platform most people use now, the one that's probably got the majority of systems on the internet is from Apache, which is actually an open source system, so you can just go and download it and put it onto a computer, and basically you have a server that's accessible on the internet or through the World Wide Web on the internet. You need to get a domain name, which basically is the www. We see it as the www dot something, Amazon.com, Verizon.com, NewYorkTimes.com, CNN.com, so on and so forth. Right? So that's a name that's actually central, that is registered. You can go out and buy it, lease it for X period of time. You need to know how to write web pages in HTML. So that is web. It is It's kind of programming, but it's pretty straightforward stuff. Basically, what HTML does, HTML stands for Hypertext Markup Language, and what it does is it's a series of instructions that when a browser reads it, it will do what the instruction tells it to do. So say, for example, if you look on an HTML page, you'll see a header, all right? And when the browser sees that, what it will do is it will draw a header onto the screen. Right? And in addition, you also need to understand there's other things around networking and getting things up, being able to do technical issues that are associated. But all in all, there's not a lot of barriers to being able to get a node up onto the web. All right, and there was a rise, what we call the rise of the webmaster, which was the creation of kind of a job. So that was a kind of a new job that was involved with being able to set up the technical infrastructure to run stuff on the web, be able to write content that can be displayed on the web, which is kind of part and parcel of what we call this webmaster role. So Web 2.0 is really kind of where we would mark kind of the start of Web 2.0 in probably post internet bubble, the dot-com bubble. When that burst, it was kind of about a year or so afterwards, you started seeing kind of new utilization, new uses of the internet. And big emphasis on Web 2.0 was around this idea of online content. So this would have been in the 2001, 2008, 9 time frame. All right. And so you saw a lot of additional content, additional utilizations of things we see, things we see now, like blogging, was something part of Web 2.0, the ability to actually easily put content, be able to capture content, and be able to publish it for access. Another big piece of Wikipedia, which is really a global encyclopedia, but it was really formed as basically uses a wiki, which is basically a type of web application, and put out there so people could just go out and add their own content. What you have is basically a global encyclopedia. And the people who work with that stuff, you don't need to know HTML. You don't even really know the web server. You just log on, you can add content to it. Some a huge growth around things like that. So you saw kind of a second bubble coming out of this, kind of coming as this stuff kind of matured and people kind of got over some of the early failures. You saw kind of a whole new area of explosive growth, which was like early days of MySpace, which I think it still might be around, but kind of was an early on adopter of social networks. Facebook, Twitter, which I think are kind of the mainstream ones we see now. Instagram, which deals more with photographs, which is a little bit later, but it's all within that kind of. So all the stuff taken together is what we call Web 2.0. So some terminology, the words, if you want to sound like you're talking about with the internet, a couple things. So, a packet is really a unit of data that gets passed across the network. So, what happens, you'll hear people talk about the internet like packet. You'll hear the term packet get thrown around. Basically, it's, a chunk of data that gets moved around, and it takes multiple chunks of data to actually, like a web page is made up of, multiple chunks of data kind of reassembled, broken apart, sent, and then reassembled. A hub is a network device, which is kind of an older network device. It connects other devices together. Kind of an early, what you do is in order to have X number of devices talking to each other, you need to have a means by which they all would interconnect. The hub was kind of the first generation of stuff that was built around that. Now we see more of talking about switches. So hubs and bridges were kind of the first generations of these things on networking. Now it's much more, the world is built around switches and routers. So switches are a network device with packet filtering, basically used around local area networks to interconnect things like within data centers or within a site. Routers are a different type of device that receives, analyzes, and routes packets across the wide area network. So both, the world right now, if we look at like using an example from where I'm at right now, in Campbell's, data centers that are supporting Campbell's right now is made up of a whole bunch of switches and a whole bunch of routers that are all basically, everything is interconnected through them. An IP address is a unique identifying number for a device on the internet. Every IP address should be unique. Theoretically, if you put two out there and they collide with each other, it will cause problems. So it's a unique identifier characteristic of that. A domain name is really just an IP address, but it's also a human understandable name. So an IP address will be represented as 4 octets. So 128.254.001.005 would be an IP address. A domain name is basically a human version, a human understandable version of that name. So, a domain name would be www. We know it was www name, so www.amazon.com is a domain name, but behind that there is a 128.192, some sort of IP address associated with that. DNS is a tool that enables the ability to map a IP address to an IP name, so you can find things and search things. Basically, the heart of getting from one place to the other on the internet is the ability to translate a domain name into its matching address. Packet switching is the function that a router serves. It moves. It'll take packets in, try to figure out where they're supposed to go, and route them to another destination until it ultimately is found. So the internet is all based upon there's a whole bunch of routers sending packets back and forth, and ultimately looking for targeted destinations. And a protocol is, we talked about TCP/IP being a protocol. Protocol is the rules that allow messages to talk to each other. And what happens is, and it's a piece of software. TCP/IP is implemented as a software, but it's a bunch of rules. And if all the machines are talking TCP/IP, you're able to send a message from one machine to the other and have the other one both recognize what's coming in and then be able to respond to it. Broadband is a type of communication. So modern, you look at this is kind of more of the modern approach to the internet. Original access to the internet was through modems. So you would dial up to a site, which would then interconnect you. And it did work. So the speed was not good, but it would work. So what you saw was a lot of the reason it was able to work was actually websites were much less sophisticated, had a lot less content, had a lot less functions that you saw. So websites, like if you look at the first Amazon site, it looks pretty cheesy compared to what we see now. And part of that was because of the bandwidth. Now what we see with broadband, which is really a network interconnection, up over 256 bits per second, which is a pretty robust. All right, and you can use broadband can be implemented either through cable or DSL or satellite. So it can be implemented a couple different ways. The thing to always remember about it, though, it's really the characteristics of broadband is basically it's a relatively high speed, greater than 256. And what you see is it's how much you want to spend on speed. You look at commercials for Comcast. They put a big emphasis on faster and faster and faster and faster. T1 and T3 is basically once again more bandwidth. So bandwidth is always the king of everything on the network now is bandwidth, and how much bandwidth, which makes basically how much information you can pump through it. It's kind of an interesting aside here, the kind of the power of broadband, the ability of the internet. The thing that makes the internet work is the fact that its reach and its ability to connect. So in 2001, there was actually a resolution put forth by the UN talking about one of the things that would be important moving forward would be the ability to connect to the internet as a means of connecting into the world. So it's a pretty significant it's a pretty significant piece of technology. It's basically people are using it all the time. It's really it's actually kind of a remarkable an accomplishment as you kind of look at what it is. And I think it is going to be continue to have impact as we continue to move forward. So wireless technology, basically what wireless is just basically basically passing the internet um, access to the or through TCP/IP through an internet signal into a radio signal. So wireless is really radio. All right. And first generations of it was something we called 802.11b. These are all standards. So 11b, 11g, and 11n are kind of the evolutionary standards. So they respond. They have different speeds and different functions. But basically, the function you have is a wireless access point, which is really just a signal. Your machine, your laptop, your phone will talk to the wireless access point, which will then be connected into the internet, which will then communicate. So it's really kind of wireless replaced wired technology. First generations of internet access or computer access, everything was plugged into a hub or a switch. Now with wireless, you still have things are plugged into hubs and switches, but like endpoint devices like laptops and phones, more often than not, will be connected with the simply use wireless access. So wireless has really become very ubiquitous. Kind of all you see it. People with expectations, you can always get a wireless signal. But that is also kind of a physical. It's connected to like a physical infrastructure. Mobile networks is basically running internet across telephone, right? So telephony. So you use cell phone. And you can move. Basically, you can move TCP/IP over a cell phone. Right? So, we saw the explosion of this, the invention of the release of the iPhone, and the idea of cell phones. Every cell phone now has internet access. Early generations of this stuff with 3G networks, it worked, but it wasn't necessarily the fastest. All right, and then 4G, which is actually pretty close, much closer to home connection speeds. Right, so this is so we've seen to go from 3G to 4G, and then the distribution of signals so you can get it wherever you're at. And it's taken a while to get there, and you still have depending upon your vendor. What their coverage is. It's one, coverage is always a big issue with this stuff. Bluetooth is a kind of a specific short-range networking that really is designed to replace wires. So you go wireless. Bluetooth actually had been around a while. It kind of got big when cell phones came out and people needed to be able to use it for cars or use it for using cell phones in cars or cell phones for like headsets. You saw a lot of that. You see a lot in consumer goods. All right, and then voice over IP, or as we call it, VoIP, is basically converting sound into digital signals and then sending it across the internet. Telephony, if you look at telephones really kind of have worked as in their own universe, as a parallel universe to the internet. Right? And it's actually much longer, so it goes back to the days of Alexander Graham Bell. But the way telephones work is it just basically translates sound waves into electronic signals, sends the electronic signals, and to a receiver, which then translates it back into sound. The problem is it's done through an analog circuit, so what happens is any sort of interference will show up as static on the line. What happens with voice over IP is that the signals, basically the sound waves, are converted into, instead of just simply electric signals, they're actually converted into a digital pattern. The digital pattern is sent via packets to a destination, which is then translated back into the sound waves, which are then presented back. So it's seeing a lot of IP. Skype is voice over IP. You're seeing a lot of different applications of voice over IP. So it's a pretty big part of what we're seeing now. Like the older, what they call POTS, which stands for plain old telephony systems. Probably, they're still around, but not, they're not the only way of doing this stuff. So organizational networking, how this stuff is structured, there's kind of a hierarchy. You have a LAN, local area network, which is really defined as a network within the same building or within a campus, fairly short, basically bounded by, an organization or some sort of facility. A WAN, local area, so LAN stands for local area network. WAN stands for wide area network. So it's a network that spans different locations, different cities, states, globally. A wide area network is really, longer distance beyond, measured in feet, or miles, it's measured in hundreds of miles, thousands of miles. A MAN is a network in a metropolitan area. So you'll see it like, for example, in downtown Philadelphia, you'll have a MAN, being able to connect, a campus together, like a University of Pennsylvania is tied into a MAN. So you've got things, kind of, the key issues, the key part of this is it's part of a metropolitan area. And then the intranet and extranet. And intranet is really the internet that is separated off and protected from the internet. So the way the internet works is the internet is designed to connect to anything, right? So theoretically, if you plug into the raw internet, anybody who's on the internet can also access your device. And intranet is, and we'll talk about this a little bit, when we talk about security. An intranet is bounded by what we call a firewall. A firewall is a device that basically will serve as a gatekeeper, taking information as it comes in from the internet and determining whether or not it can pass through to a destination on the intranet side. All right. The intranets are usually bounded by like companies or organizations. A house theoretically, if you have your home with a wireless modem and broadband connection, your house is technically an intranet. All right. So basically, and it can be of different sizes, but it's an internal network access. It's sort of uses the same internet technologies and capabilities. It's just simply bounded off and secured. An extranet is within that is another term for another kind of implementation, basically where if multiple companies have share a common internet. For example, between Campbell Soup here and Wipro, there was an extranet that has been established that two organizations use as part of their operations. So just a couple other little bits of information here, just to kind of as we wrap this thing up. SharePoint, which is it's really a collaboration platform. So there's a whole bunch of these things. Google Plus is a collaboration. So the idea is that SharePoint is a product made by Microsoft that enables people to share information, be able to store information, interoperate collaboratively. It's not the only, SharePoint itself is a product. It's not the only product of that nature. You're seeing more and more of these things that are very, have a similar kind of capability, both with Google or other types of providers like that. So if you look at Google, like I said, if you look at what we're using with Google Plus, has a very similar kind of capability. It runs on the internet. We talked a bit before about cloud computing. Cloud computing is based upon the internet. So the way you get to a cloud is through the internet. If you don't have the internet, you don't have any access to a cloud. Right? And then we talked about Metcalfe's law. So it's really, we talked about Moore's law before. So Metcalfe's law is kind of a variant or a form of this related to networking. So the term, the way it's constructed is it defines the value of a telecommunications network is proportional to the numbers of connected users squared. So basically, the more people you have onto it, the more valuable it becomes. So the idea is, if you only have two people on the network, you only have a dialogue between two people. If you have an internet where everybody on the planet could theoretically talk to everybody else, you see the difference between, the scale and the proportion, kind of what the value of the potential value associated with the internet, because you can really reach anybody at any location. All right. So these are just some of the study questions. You can just take a look at them. You know, basically, the terminology we're talking around switch, router, IP address, kind of the history of the, things you want to maybe focus on is also, kind of understanding kind of the history of how the internet came from kind of a research organization, a research basis became a commercialized and, a commercialized platform over time. And the difference between Web 2.0 when Web 1.0, which is kind of the first generation of web technology, to kind of Web 2.0, which is this kind of what we see now. We're using a lot more content, a lot more collaboration, in addition to some of the original commercial things. And that is about it. Thank you.